Greetings, math fans. All right, so this is our review sheet for probability, so let's get started. If you study for this math test, that's a coincidence that we're having this question here. So if you study for this math test, there's a 65% chance of getting a B or higher. So if you study, that's your given. And there's a chance of getting a B or higher. So that's your probability. Okay, so you'd write this, the probability of a B or higher, given that you study. So that's 0.65. Okay, and then it says there's a 45% chance you'll study. So the probability that you'll actually study, better be higher than that, that's all I can say, is 0.45. Okay, so if you remember our old formula, and I'll do this in terms of, if I say probability of B given that you studied, that's equal to the probability of getting a B and studying divided by the probability, remember the study goes down here, probability of study. Okay, but the deal here is we're solving for this guy right here. Okay, so again, you just cross multiply. I mean, you can solve. So the probability of B and study is those multiplied together. So the probability of studying times the probability of a B given that you studied. Okay, so basically what we're doing here is I'm solving for this guy, I'm just multiplying these two together. Okay, so it is 0.45 times 0.65. So my answer is 0.29. All right, moving on. Okay, so you're going to Six Flags this summer. Ooh, that's exciting. 35% of the roller coasters go upside down. So let's write this out here. So the probability of upside down is 0.35. And the probability of roller coaster, 42% of roller coasters have a steep initial drop. So the probability of a steep drop is 0.42. Okay, and 21% of the roller coasters go upside down and have a steep drop. So the probability of upside down and a steep drop is 0.21. The question is, you're definitely going on the roller coaster. So that's your given. So this is given here. You're definitely going on the roller coaster that has, You're definitely going on a roller coaster that has a steep drop. So what's the probability that you'll choose, that your roller coaster you choose will go upside down? So really, this is the probability. The probability that you're going to go upside down, given that it's a steep drop. Okay? And that, of course, is the probability of upside down and steep drop divided by the probability, remember, it's the probability of the steep drop. Okay, so that is going to be 0.21 because we have figured out already, divided by probability of steep drop, which is 0.42. So the answer is 0.50. Okay? All right, moving on here. Given the following table about sports cars and luxury cars at the Mercedes dealership and whether they are red or black in color. A car is selected at random. What is the probability that the car is red? Well, there's 253 cars and there are 116 red cars, so it's 116 over 253. Okay, what's the probability the car is a sports car? Well, how many sports cars are there? It's 130 out of 253. So 130 out of 253. Okay, that's pretty easy. What's the probability that the car is a sports car given that the car is red? So I know that the car is red. So right here. And how many red cars are there? They're 116. Okay, so I have 116 on the bottom, total to choose from, and then how many sports cars are there? There are 78 sports cars. So the answer is 78 over 116. That does reduce to 39/58. Okay, and the last question, your teacher wants a sports car. That's me. Okay, so what is the probability that the car is black? So I know it's a sports car. That means we are right here. So there's 130 people, 130 sports cars. So that's my denominator. And the top number is what's the probability that the car is black? Well, there are 52 black sports cars. So it's 52 over 130, or 2/5. Okay? All right, moving on. Okay, you go to Kohl's and buy some Chicago sports shirts in different sizes. These are the teams and the sizes left on the rack. So you have small Bears, a small Cubs, a small Black. Well, you can read them all. I'm not going to read them all here. Okay. So the key is there are 14 items. If you count all of them, that's important. So 14 items. Okay. Find the probability that it's a small size. Well, how many small sizes are there? 1, 2, 3, 4. So it's 4 out of 14, or 2/7. What's the probability it's a Cub shirt? Well, how many Cub shirts are there? Small Cubs, so it's 1, 2, looks like just 2. So 2 out of 14, or 1/7. Okay, that's pretty reasonable. Okay, now this is conditional. What's the probability that it's a White Sox shirt given that it's an extra large size? So I'm telling you it's extra large. So how many extra larges are there? 1, 2, 3. So 3 is my bottom number. And how many White Sox? There's 2 White Sox shirts, so it's 2/3. Okay, what's the probability? It's a small size given that it's Bears. Okay, a Bears shirt. So how many Bears shirts are there? There's 1, 2, 3, 4, 5, I believe. Right? Am I good here? 1, 2, 3, 4, 5. Yep. So there are 5 Bears shirts. And how many small Bears shirts are there? 1. So it's 1/5. Okay, these are easy problems, just looking at that chart. Okay, so what is the probability of a medium size and a bear? So you basically just look for medium size and bear. Both have to be true. And if you, I just circled it already here, there are 2 medium Bears shirts. So it's 2 out of 14. It's pretty easy. 2 out of 14, okay, or 1/7. What's the probability of large and Cubs? So let's go to the large. How many large Cub shirts are there? Oh, there are none. 0. Medium size or. Okay, look at this. Here's the or. Here's another or here. I can highlight that one too. Okay, as opposed to this one is and this one's and. Both have to be true. Or is one or the other, but not both. Right? You got to subtract the overlap. So how many medium-sized shirts are there? I'm not going to go up to the top because you can just look at it. But there's 4 medium-sized shirts. And how many Cub shirts are there? There are 2 of them. Okay, but I count medium in the medium-sized and the Cubs. I counted this one twice. So that's why you subtract the overlap. So you subtract the overlap. So it's minus 1 over 14. So that gives us 5/14. Okay, a small size or White Sox. How many small sizes are there? 4 out of 14. How many White Sox shirts are there? 3 out of 14. And are there any small White Sox shirts? Small White Sox. Nope. No overlap. So that's it. No overlap. So that's answer is 7 out of 14, or 1/2. Okay, moving on. Okay, now we got the tree here. It's kind of big to fit on the screen here, but anyway, you got the probability of owning a dog and not owning a dog, and then probability of owning a cat and not owning a cat. All right? What's the probability of owning a dog and not owning a cat? So I'm going to highlight it. Owning a dog and not owning a cat. So that means it's 0.6 times 0.8. Okay, so 0.6 times 0.8, which is 0.48. Okay, what's the probability of owning a cat given that you own a dog? Okay, so let me just erase this here. Okay, so again, the probability of owning a dog or owning a cat given that you own a dog. So you already know you own a dog. So you don't have to do anything with this. I'm already there. So if I'm right there, what's the probability if I own a dog already? What's the probability that I own a cat? 0.2. Okay, so that one's 0.2. Next question. What is the probability of owning a dog given that you own a cat? So we're going to write this out because this one's a little bit more involved. So let me actually go to this. Okay. The probability of owning a dog given that you own a cat. So I'm trying to figure out this one right here. But I own a cat. So I'm either here or I'm here. One of the two. And that's a conditional probability. I know I own the cat. Okay, so let's go down to here. Let's just actually write this out. Technical difficulties here. Okay, the probability of owning a dog given that you own a cat. So that's the probability of a dog and cat divided by the probability of a cat. So the probability of a dog and a cat, if I go up here, a dog and a cat is right here, only a dog and a cat. So it's 0.6 times 0.2. So 0.6 times 0.2 divided by probability of owning a cat. Well, that was a little tricky because you either own a dog and a cat or not own a dog and a cat. It's one of these two, this one or this one. So it's two different probabilities here. It's 0.6 times 0.2. So 0.6 times 0.2. Or, that's why it's plus, I'm not owning a dog, 0.4 times 0.7. Okay, and that goes on the bottom. So 0.6 times 0.2 plus 0.4 times 0.7. So don't forget to put parentheses around this bottom, guys, and the answer is 0.3. Okay? All right, two more for this one. It says, what is the probability of owning a cat? Well, that's what this is right here, guys. This is the probability of owning a cat. Okay, right there, probability of owning a cat. So if you put that in your calculator, just that part, you get 0.4. Okay, what's the probability of owning a dog? Well, that's easy. Just look at it. Probability of owning a dog is 0.6. So 0.6. Okay, ooh, there's my birthday, 4/6. Okay. Moving on to number 6. It's kind of a longer packet, but it's okay. It just covers everything. All right, the probability that the Cubs will win the World Series is 0.31. Pretty good. The probability that the Bears will win the Super Bowl and the Cubs will win the World Series is 0.18. The probability at least one of the two teams will win the championship is 0.42. So I'm going to kind of draw this relatively quickly here. So if I call this Cubs and this is the Bears. Okay, so we'll try to do different colors here. Probability that the Cubs will win the World Series is 0.31. So we'll do that in purple. Okay. So that whole thing is 0.31. 0.31. Okay. And then the probability that the Bears will win the Super Bowl and the Cubs, that means it's the middle section here. So that's 0.18. And the probability that at least one of the two teams will win the championship is 0.42. So this whole thing is 0.42. Okay, these are just like the problems we've been doing. All right, so before I start anything, I want to actually figure out the probability of only Cubs and the probability of only bears. Okay, so only Cubs. Do you guys agree it's the purple minus the blue? So 0.31 minus 0.18. Okay, which is 0.11 or 0.13. Okay, and then only the bears is going to be 0.42 minus the purple, because that's only the bears. It's all the big Cubs thing. So minus 0.31, which is 0.11. Okay, that's all I need for this. The rest of these answers. Find the probability of neither team's winning the national championship. Well, it's 1 minus 0.42, which is 0.58. Okay, find the probability of the Bears winning, but not the Cubs. We already did that up here. Only the Bears, so 0.11. We did that. And find the probability of exactly one team winning the national championship. Okay, so it's only the Cubs plus only the Bears. So 0.13 plus 0.11, which is 0.24. Or you can say 0.42 minus the middle section there, which is 0.18. That gives you the same answer. Okay, moving on. In a coin collection, there are 9 pennies, 8 nickels, blah, blah, blah. A coin is selected at random. What is the expected value? Okay, it's got a lot to it, but first of all, there's 60 coins. So it's 9 out of 60 for a penny, and you win a penny. And there's 8 out of 60 for a nickel, and you win a nickel. And there's 12 out of 60 for a dime, and there's 16 out of 60 for a quarter, and there's 11 out of 60 for a $50, and there's 4 out of 60 for a buck. Multiply it all out, you get 0.25. That's your expected value. Okay, so every time you do it, you might win a quarter, but you might win 10 cents or 5 cents, but on average, you'll win 25 cents. What's the expected value of a fair game? 0. Okay, a pair of dice is rolled depending on the sum of the dots. You can win or lose money. Okay, so let's make a dice chart here. Okay, give me 2 seconds here. Okay, a little messy, but good enough. All right. So to roll, and you can look at all these, you just get these probabilities here. Okay, how many times there are. So if I want to get a 6, 8, or 9, there's 14 ways. 2, 4, 5, there's 8 ways. A 10, there's 3 ways. A 3 or 12, there's 3 ways. And a 7 or 11, there's 8 ways. Okay, so they should add up to 36, which I think it does. Okay, so again, this is pretty easy once you have that, because it's 14 over 36 times 6. You win $6, plus 8 over 36, and you lose $4, plus 3 out of 36, and you win $7, plus 3 out of 36, and you win $5, plus 8 out of 36, and you lose $1. So multiply all it out, and you get positive $2.22. So I'd play that game. So on average, you're going to win $2.22. Okay, on average. All right, cool. Moving on. Card is drawn from a deck of 52 cards. Find the probability that the card is a black 4. So this is only a 1-card pick here, and there are 2 black 4s. 2 out of 52 over 1 over 26. Okay? A king or an ace. So these are independent because there's no king ace. So it's 4 out of 52 plus 4 out of 52. No overlap because they're independent. That gives you 8 out of 52 or 2/13. A 6 or a club. Well, how many 6s are there? There's 4 out of 60 or 52. There's 1/4 clubs, but there is a 6 of clubs. So minus 1 out of 52. That's the overlap. So that's 4 out of 13. A face card. There's 12 face cards out of 52. How many diamonds? A 4th of them. And how many face card diamonds? Well, there's 3. So minus 3 over 52. So your final answer is 11 over 26. Okay, 2 dice are rolled. Find the probability that at least one of the dice shows a 3. So I'm just going to copy this dice chart here. Give me a moment. Okay, so we have our dice chart here. So what's the probability of at least one of the dice showing a 3? So here's the deal. It's this guy here or this guy here. So if you count those, you get 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, we get 11. Okay, so it's 11 out of 36. They show the same number. That's the doubles. So 1, 1, 2, 2, 3, 3. So there's 6 out of 36, or 1/6. The sum is more than 12. Impossible. So 0. The sum is 8, or the sum is less than 6. So if its sum is 8, let me get rid of these guys here. Okay, so let me highlight that. Sum is 8. Okay, or the sum is less than 6. Okay, so you just add all those up and you get, so here let's do 5 over 36. That's 8 plus 10 over 36. No overlap, so we get 5/12. Okay, the sum is at least 8. So just count them up and it's 15 over 36. Okay, or 5/12. Pretty easy. All right, committee of 5 people is to be formed from a group of 7 men and 6 women. What is the probability the committee will consist of 3 men and 2 women? So it's 3 men and 2 women. Word! Or is it word? It's in any order. So of course it's a word. Okay? Because you're not picking one person specifically first and second. It's 3. I gotta have 3 people, 3 men and 2 women. All right. So that's going to be, and then and of course no replacement. So 7 over 13 times 6 over 12 times 5 over 11 times, now we get back to the women, so 6 women out of 10 times 5 over 9. Okay, and then it's times 5 factorial over 3 factorial, 2 factorial. Make sure you put parentheses around that bottom number, guys. If you don't put parentheses around there, you're going to get it wrong. Okay, so my answer is 175 over 429. Sorry, it's very messy. 129. Okay? All right, what is the probability that we'll have at least 4 women? So it's 4 women, 1 man, or 5 women, or 0 men. Okay, so that's a word. These are words again. So it's 6 out of 13 times 5 over 12 times 4 out of 11 times 3 out of 10 times, and then that's 4 women times 7 out of 9, and times 5 factorial over 4 factorial times 1 factorial. Okay, or same thing. So 6 over 13, 5 over 12, 4 out of 11, 3 out of 10, but now it's 2 out of 9. And you could do 5, it's 5 factorial over 5 factorial, which is really 1, but just to show my work. Okay, so that, again, that's or is a plus sign. Okay, so multiply all that out and we get 37 over 429. Okay, moving on. We're getting there. How are we doing? Okay, still got a little ways to go here. Okay, number 13. What is the probability of selecting a king, followed by a jack, if the first card is replaced? So, of course, it's 4 out of 52 times 4 out of 52 because it's replaced. So it's 1 out of 169 reduced. The first card is not replaced. So it's 4 out of 52 times 3, I'm sorry, times 4. 4 out of 51, because it's different. It's a jack. Okay, so that gives us 4 over 663. Okay, out of 120 students, 60 are taking French, 50 are taking Spanish, 20 are taking both French and Spanish. If a student is selected at random, what is the probability that he's taking French or Spanish? Well, that's easy. It's just 60 over 120 plus 50 over 120 minus the overlap. So it's 3/4. Okay. 15. You draw a card from an ordinary deck of cards. Note that it's a queen, then replace it. Draw a second card. What's the probability that the second card is a queen? Well, there's just 4 out of 52. Especially because I replaced that one. So it's completely independent of anything I've done. I could have picked 5,000 cards before that. As long as I replaced them all, it's still out of 4 out of 52. Okay, 16. Probability that Jack gets an A on his math test. All right, Jack. Nice. Is 0.98. Well, the probability that Jim, all right, Jim, gets an A on the same test is 0.6. What is the probability that they will both get an A on the test? Okay, well, that just multiply them together. 0.98 times 0.6, so we get 0.59. Okay, a batter is now hitting .200. And the next 5 times at bat, what is the probability that he will have exactly 3 hits? Totally binomial. Totally binomial. Okay, so it's 5 hits, he's getting 3. It's really messy, sorry. And then my success rate is 0.2, my failure rate is 0.8. So the 3 goes here and the 2 goes here, because they have to add up to 5. Okay, so my answer is 0.05. If attack is dropped, what is the probability that it will land point up is 2/5? 10 attacks are dropped. What's the probability of exactly 3 landing up? Success or failure, another binomial. So it's 10C3. And success is 2/5 and failure is 3/5. So that's a 3 here and a 7 here. So the answer is 0.21. Okay. Getting there. Getting there. Jack is taking, another Jack problem. All right. Jack is taking a multiple choice quiz, which consists of 6 questions. We've seen this problem before, that have 5 possible answers. If Jack guesses on every question, what's the probability he will get 4 or more correct? Okay, so that's binomial again, 64. Since there are 5 possible answers, success rate is 1/5. Failure is 4/5. So it's 4 and a 2. Or that's 4 correct. 5 correct is 65. So it's going to be a 5 here and a 1. Or all of them correct. 66. 4/5, 1/5. So it's going to be a 6 and a 0. Okay, so you get 0.02, which makes sense. Okay, if you're guessing and to get 4 more correct, it's pretty small. You're probably not going to get any correct at all. All right, 20. What is the probability of winning a raffle? Which said the probability of winning a raffle is 2 over 92. What are the odds? Well, that's easy. So if it's not, if it's 2 over 92, and this is the probability, so that's success, and that's total. So failure is 92 minus 2, minus 2, which is 90. So odds are success over failure, so 2 over 90, or 1 over 45. Okay? The odds of picking a red Skittle are 4 to 11. What's the probability? Again, 4 is your success. Failure is 11. So total is 4 plus 11, which is 15. So the probability of Picking a red Skittle is 4 over 15. All right, getting there. You flip a coin 10 times. What's the probability that you'll get tails 3 times? Totally binomial. You're flipping it 10 times, and what's probably getting it 3 times? So probably getting a tail is a half, and a head is a half. So 3 goes here, and 7 goes here. So your answer is 0.12. Okay, you enter a raffle for $5. So the deal is, this is an expected value problem, by the way. You lost $5 no matter what. So the probability of losing $5 is 1. And there's 1,000 tickets. Now we're assuming that you're putting the ticket back in, just to make it a little more simple. Okay, it was one grand prize at $200, so it's the probability of winning that is 1 over 1,000, and you win $200. Okay, the probability of the second prize, which is 3 out of 1,000, you're going to win $50. Okay, and you put that all together, you get negative 4.65. Okay, and that's dollars, right? I would not play the game unless it's some cute little Cub Scout or Boy Scout with sad eyes saying, please buy a ticket. And I'm like, okay. Number 24. You roll a 6-sided die, one 6-sided die. I don't need to make a dice chart. What's the probability that you will roll an even number or a number divisible by 3? So an even number is 2, 4, or 6. A number divisible by 3 is 3 or 6. So that's 3 over 6. That's 2 over 6. But I counted the 6 twice. So minus 1 over 6. So the answer is 4 over 6, which is my birthday, and or 2/3. Okay. All right. Oh, almost done. Woo! Okay, there are 4 red buttons, 3 green buttons, and 6 blue buttons. What is the probability that you pick 2 red buttons and 1 blue button? So again, there's no order here, math fans. So, and if it doesn't say anything, it's with replacement. Okay. All right, number 25. There are 4 red buttons, 3 green, 6 blue. What is the probability that you pick 2 red buttons and 1 blue button? So again, order doesn't matter here. You're just picking them, right? I didn't say anything about order. So whenever there's no or any order, you got to say what? I can't hear you. Word. Okay, so this is going to be red, red, blue. So the probability of picking a red, 4 out of 20. And again, if it doesn't say anything, it's you're not replacing it. Always think of cards, right? Cards is the standard. So with a card, you don't replace it. You don't deal somebody an ace and then take it back and deal somebody another that same ace. Okay, so it's no replacement, and it's in any order because I can take my cards and I can put them in any order I want. Okay, so 4 out of 20, 3 out of 19, and 6 out of 18. That's the number of blue buttons. And then, of course, it is 3 factorial over 2 factorial, 1 factorial. Okay? Make sure that's in parentheses in the bottom. So your final answer is 3 out of 95. Okay, B, you pick 3 green buttons and 2 red buttons. Okay, same situation, except it is just green, 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 and red. Sorry, red, red, red. There we go. Okay, so we got 10 out of 20, 9 out of 19, 8 out of 18, and then the red ones, which is 4 out of 17, and 3 out of 16, and then it's 5 factorial over 3 factorial, 2 factorial. Okay, so you come up with 15 over 323. Okay, so good. You pick a green button and then a red button and then blue button and then 2 red. So there's an order here. So there's no word. So this is order. Okay, so it's going to be 10 out of 20, 6 out of 19, and then 4 out of 18, and 3 out of 17. Okay, so that is, and then again, there's no order, so it's just 2 out of 323. Okay, you pick 2 blue buttons and 3 green with replacement, so that's different. Okay, and again, there's no, or it's any order, any order. So that means word. Okay, and by the way, it's blue, blue, and green, green, green. Okay, that's your word. So it's going to be 6 out of 20 times 6 out of 20 times 10 out of 20 times 10 out of 20 times 10 out of 20 times 5 factorial over 2 factorial, 3 factorial. Okay, so it gives you just 9 over 80. Perfect. Okay, next one here, you pick 2 red buttons, then a green, then 2 blue with replacement. So definitely in order. So it's order, so it's not a word. Okay, only when it's any order is a word. So we're going to do 4 out of 20. It's with replacement. So 4 out of 20. It's 2 red buttons, and a green is 10 out of 20. And then 2 blue, 6 out of 20, and 6 out of 20. Okay, so it's 9 out of 5,000. Okay, and last one. You pick 5 buttons with at least 4 of them green. Okay, I'll tell you, man, do not forget this one. So in other words, it's going to be green, 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 green. Again, any order. So for green and other, I'm going to put an O. And the other one's going to be green, 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 green. So 5 greens. All right. So the probability of picking a green, again, it's with replace or without replacement as typical. So 10 over 20 times 9 over 19 times 8 over 18 times 7 over 17, and then other. There are, obviously, there's red and there's blue. So there's 4 red and 6 blue. So it's 10 out of 16. Okay, and then times 5 factorial over 4 factorial, 1 factorial. Plus, it's almost the same thing. So 10 over 20 times 9 over 19 times 8 over 18 times 7 over 17 times 6 over 16, and then times 5 factorial over 5 factorial. Okay, so you add all those together, and well, here it's the first one's 175 over 1292. Don't forget, put the parentheses around these on the bottom here. Okay, plus 21 over 1292. So my final answer is 49 over 323. Okay, so that was it, man. That's like a 35-minute video, and hopefully you guys do well on this test tomorrow, because the problems are really similar to this. And just study hard. Have a good day, math fans. Adios. Goodbye.